Hello everyone and welcome to the Unit 2 review session for Honors Chemistry. Let's talk a little bit about the format of your test before I go over the review session problems. All right, on your test there are going to be 15 multiple choice questions. Okay, and those can span from any portion of the unit that we have gone over. All right, there will be 3 free response, and these can include your different calculations you have to do, dealing with the atom, number of protons, neutrons, electrons, average atomic mass, any of the wave problems, any of those will be in there. Then there will be 2 elements that we ask for: the electron configuration and the electron filling diagram. Okay. All right. In addition, you will have your elements portion of the test. There will be 10 elements that we give you the names and you have to give us the symbol. And then there will be 10 where we give you the symbol and you have to give us the name. All right, you'll all be given a periodic table to use. Depending on your teacher, it'll look different. There will be no names on these periodic tables, but any number you need will be listed on these periodic tables for you. In addition to the periodic table, all right, so you'll be given a periodic table. You will be given Planck's constant. All right, so you will have Planck's. And you will be given the conversion from meters to nanometers. Those are the only things that you are given. Otherwise, you are responsible for any other equations and certainly the speed of light constant, because that's important to know just in general. All right, so we're going to have 10 questions to go over today. All right, that span the entire unit. Just as a reminder, you should be doing all of the practice sheets in the packet, all right, and the review sheets, and any other assignments that your teacher has given you to reinforce the material. Anything in Unit 2 is fair game for this test. So number 1, how many protons, neutrons, and electrons are in an ion of bromine 80? So a couple of things. Well, first of all, this is bromine, and the symbol for bromine is Br. You need to know that. I'm asking for an ion of bromine. Well, bromine is in group 17, and as we went over in your notes, group 17 all has a charge of -1. All right, so figuring out your protons, neutrons, and electrons. Well, I'm going to look at my periodic table for bromine. And on this periodic table, hopefully you can see it okay on the recording. All right, the atomic number of bromine is 35. We can see there the atomic number is 35. That means that bromine has 35 protons. Anything with bromine in it is going to have 35 protons. That is how it gets its identity. I have told you that it is an ion of bromine, and it is in group 17, which means it's -1. So we don't just write the symbol like this, we write the symbol with a negative sign. You can write -1 if you want to. I typically don't, and I just write the negative sign there. Because it is -1, that means it has 1 more electron than it does protons, because it has an overall -1 charge. So that means I have 36 electrons in an ion of bromine. The final number I need is my number of neutrons. Well, if I tell you it's bromine 80, or I could have written it Br-80, 80 is your mass number. And we know that mass is equal to your number of protons plus your number of neutrons. So if you know that it is 80 as your total mass, 35 of those are coming from your protons. All right, you're just going to subtract 35 from 80, and you will see that your number of neutrons is 45. Okay, so 45 neutrons. All right, please make sure when it comes to these problems that you do know the periodic trend for the charges. This is under oxidation number in your notes, where group 1 is +1, group 2 +2, group 17 is -1, group 16 is -2, aluminum +3, zinc +2, and silver +1. Those are ones you do need to memorize, so please make sure that you are comfortable with that from your notes. All right, so let's take a look at number 2. What is the average atomic mass of element X if 40% has a mass of 12 AMU and 60% has a mass of 10 AMU? All right, in this problem, we're looking for average atomic mass, which means that we are going to be doing a weighted average. The way I like to do the weighted averages, first off, I like to ask myself, okay, can I figure out what my answer should be between? Well, you're averaging 12 and 10. So your answer must be between 12 and 10, or between 10 and 12. All right, but it's going to be a weighted average. So we're going to do this like this. So I'm going to take 12, my mass. How often does 12 occur? It occurs 40%. So that's going to be times 0.40. That's your 40%. I'm going to then add that to my next isotope, which has a mass of 10, and that occurs 60% of the time. So 0.6 to represent that 60%. Remember, your answer should be between 10 and 12, and we can say, all right, well, I think it's going to be a little closer to 10 because 10 occurs 60% of the time. When you put those values in your calculator, you get an answer of 10.8 AMU is your label, atomic mass unit. You must have a tenths place. If you were to round this to 11, it would be completely wrong and you've missed the point. You must have a tenths place when it comes to average atomic masses. All right, number 3. Give an example of an extensive physical property. So this is prime stuff that we can ask in a multiple choice question. All right, so a physical property, remember, is a property that does not change what that substance is. And when I say that it is extensive, that has to do with amounts. All right, how much you have. So this could be something like mass, volume. All right, those are all extensive properties, okay? If on the other hand, I asked for intensive, that's a property, that's a physical property that has to do with the type of substance. That's something like boiling point, melting point, density, any of those things that don't change just because you change the amount that you are dealing with. All right, let's take a look at number 4. What is the charge of X when it gains 2 electrons? Well, X is just any element, all right? And if I gain 2 electrons, electrons, remember, are negatively charged, all right? So if I gain 2 electrons, it's going to be X2 minus. An atom, if I use the word atom, that means it's electrically neutral. It means your protons and your electrons are the same. When you gain or lose electrons, you become an ion. Ions have charges. It's the electrons that always change. Please remember your number of protons will always be the atomic number for that element. All right, number 5. How many iodine ions are necessary to combine with a magnesium ion to form a neutral compound? Well, knowing what I do about the periodic properties and the charges, iodine here, so iodine is in group 17, which means that it has a -1 charge. All right, magnesium is in group 2, which means it has a +2 charge. Okay. Now, when I say neutral compound, I mean electrically neutral. So what I mean by this is that these ions have to come together, and when you add all of the charges up, you're going to get 0. So if I were just to put 1 magnesium and 1 iodine together, I would have a -1 and a +2. That would give me a +1 charge. So that's not going to work. With my 1 magnesium, which is 2 positives, I'm going to need 2 iodine ions in order to make a neutral compound. +2, -1, -1, that gives you an overall charge of 0. This is going to lead into what we cover in the next unit, but it is important to know about charges and ions now. All right, number 6. The identity of an atom is dependent on which subatomic particle? Your protons. This is what I was talking about back on number 4. It is your number of protons, also known as your atomic number. All right, and again, looking at any periodic table, that atomic number is going to be the number right here above that element. It is a whole number. That is what gives identity to that particular element. Okay. Let's take a look at number 7. And again, 7 was from our notes. All right, metals tend to form what type of ion? Because of their valence electrons, metals tend to have, or metals will have less than 4 valence electrons in all cases, and so it's easier for them to lose electrons, and therefore they are going to, if you lose electrons, you are going to be positive. So metals form positive ions. All right. And we call a positive ion a cation. All right, it's not pronounced cation, it is a cation. If we were talking about nonmetals who tend to have more than 4 valence electrons are going to gain electrons, all right, to form negative ions, so they can get that octet. Okay, and these are called anions. All right, so something important to remember. Now, number 8, how many protons, neutrons, and electrons are in an atom of copper-63? If I'm using the word atom, that means that it is electrically neutral. All right, electrically neutral. So your protons are going to equal your electrons. So we need protons, we need electrons, and we need neutrons. So we're going to find those protons looking at the periodic table. All right, and I am looking for copper. And copper right here, you see my pencil? Copper right here has an atomic number of 29. So that means it is going to have 29 protons. Anything having to do with copper is going to have 29 protons. Because I use the word atom, it means that the protons and the electrons are the same. So that's 29 electrons. Remember, to figure out those neutrons, you're going to take that mass number. That's the mass number. So 63 minus 29. All right. And when you do 63 minus 29, you get 34. All right. So my number of neutrons are 34. Please make sure you are comfortable doing these. You will have, obviously a good amount of questions on those in the test. All right. Okay. Moving on to number 9. Okay. What is the energy of a photon of light with a wavelength of 233 nanometers? All right, so this brings up our notes when we were dealing with energy and waves. All right, this is kind of the largest math portion that you're going to deal with on this test. All right, you need to know energy. Okay, that's what you're looking for. Well, we dealt with 2 equations, and you do need to know these equations. Energy is equal to frequency times Planck's constant, or you could go Planck's constant times frequency. It doesn't make any difference, doesn't make a difference which way it goes. All right. Our other equation dealt with frequency and wavelength, and that's where your speed of light, c, okay, is equal to your wavelength times your frequency. So these are the 2 you need to know. In addition, you do need to know that c, that speed of light, is 3.0 times 10 to the 8th meters per second. That's important enough to know and to have memorized. Okay, so I'm looking for energy here of a photon with a light with a wavelength, all right, but I'm given wavelength and I need frequency. So the first equation I'm actually going to use is my speed of light here. So I have c is equal to lambda nu. So speed of light is equal to wavelength times frequency. I'm going to solve for frequency, so I want to get frequency alone. So I'm going to divide each side by wavelength. So the frequency, which is the symbol nu, right, frequency is going to be equal to your speed of light over your wavelength. Speed of light is 3.0 times 10 to the 8th meters per second. And then your wavelength, all right, here is 233 nanometers. Now be careful, all right? This is in terms of nanometers. Your speed of light is in terms of meters, okay? So you can't leave this at 233. All I do when I take this number is I go 233 times 10 to the negative, times 10 to the negative 9th. You will be given the conversion of meters to nanometers. If you would prefer to do a factor label problem to change those nanometers into meters, you certainly could. That would be absolutely fine. All right, when you put these into your calculator, just a reminder, Please make sure, and hopefully this reads okay, you're putting these numbers properly into your calculator. 3 second E8 divided by, all right, and this is 233. Actually, I like to use parentheses, so excuse me. So parentheses, 233 second E negative 9. And then you hit enter again, all right? And you're gonna find that your frequency here is 1.29 times 10 to the 15th. Don't forget this portion on your calculator, all right? 1.29 times 10 to the 15th hertz, okay? All right, I am now going to use my energy equation. So energy is equal to that frequency, 1.29 times 10 to the 15th hertz, times Planck's constant, which is 6.6 times 10 to the negative 34th joules per hertz. You will be given this number, all right, that's not one that you need to memorize. You will be given this number in on your test. And again, when you punch those in, 1.29 second EE, all right, 15 times 6.6 second EE, negative 34, okay? And that gives you about 8.5, so your energy is about 8.51 times 10, remember times 10, to the negative 19th, and that is in terms of joules. The hertz had divided out, and there is your energy. Please make sure on any questions like this that you are showing us all of your work. All right, so you will be good to go with that one. All right, our last question. What is the electron configuration for phosphorus? How many valence electrons does an atom of phosphorus contain? And what is its oxidation number? So let's take a look. So we are dealing with phosphorus. All right, and we're gonna look on our periodic table and we're gonna find P, because that is the symbol for phosphorus. And we see that phosphorus has 15 as its atomic number. So phosphorus has 15 protons, and as a neutral phosphorus atom, it's gonna have 15 electrons. Let's go on ahead and talk about electron configuration. A lot of students, when they get their tests, they like to write the chart out, and that's totally fine. All right, I often do that myself. Students also say things like, do I have to memorize the electron configuration chart? I don't consider it memorizing, because what you're really doing is just saying the following. First energy level has one sublevel and it's called S. That S can hold 2 electrons. That's all information you need to know. The second has 2 sublevels. The first is an S, which can hold 2. The second sublevel is a P, which can hold 6. Again, you need to know that. Third also has that D sublevel, which can hold 10. Then the fourth has that F, which can hold 14. All right, I'm gonna stop there, but you would just continue on as we did in our notes with that electron configuration chart. Now, remember, the important thing about the electron configuration chart is that it does not read left to right. So you start up and you make diagonal lines. The first place electrons are gonna go is the 1s, then the 2s, then the 2p, then the 3s, then the 3p, then the 4s. There's a skip there, and that is what happens, all right? Then after 4s, 3d, 4p, and I'll just write a 5s there just to complete that portion. All right, so let's talk about phosphorus. I'm gonna do an electron configuration for it. So 1s2, that's where phosphorus's first 2 electrons go, then 2s2, then 2p6, I'm following my arrows, then 3s2, I'm gonna stop and just check how many I've used. I've used 10, 11, 12. I'm at 3s2. I'm now gonna go to 3p. So 3p here, all right, and I have 10, 11, 12. So I'm gonna go to 3p3 to give me 15. Remember, if you add up all of the superscripts, you will end up having your number of electrons. All right, fantastic, okay? The question goes on to ask, actually, before we go on with the question, I'm just going to do an electron filling diagram here, even though it doesn't ask for it. Remember, a filling diagram shows a box for every orbital. S's get a single box. P's get 3 boxes because an orbital is a pair. All right. You're going to have arrows going up and down showing the electron spin. and these are represented by those superscripts. We're going to fill up each box. We're going to put one in each box and then fill up if needed. That's why for phosphorus here, we have 3 arrows, 1 in each box for that atom. All right, now back to the question. All right, how many valence electrons? So valence electrons are your number of outer energy level electrons. It is the number. All right, you're going to look for the coefficient, the largest energy level, and it is anything after that. So in phosphorus's case, it has 2 from the S and 3 from the P. It has 5 valence, all right, electrons. And as far as its oxidation number goes, it has 5. Remember, the magic number is 8. All elements want to be like the noble gases, all right? And other than helium, all of the noble gases have 8 valence. If I have 5, it's much easier to gain 3 than it is to lose 5. So my oxidation number is going to be 3 minus for my oxidation number. All right, is -3. Also, with the periodic trends, we did have you know that phosphorus's group, which is the same as for nitrogen and arsenic, will also have -3. All right, everybody, good luck on your test and have a great day.